Hi, I'm MaryCarol Hunter. I'm on the faculty at SNEAS. I'm an associate professor. I have my PhD in ecology, but I'm also a licensed landscape architect. So I teach ecological design, among other things, and I work on the LA faculty here. What I'm going to do today is maybe slightly different from what others did. Well, I immediately got it wrong, right? I'll give you my overarching research questions, and you'll find that the things that I'm talking about today have directly to do with climate adaptation. But a lot of the work that I do is on psychological ecosystem services. So if you come to the lightning talks for the built environment, you'll hear about that part. So for all of the research I do, I would say that the two key questions are how to design cities to better support environmental and psychological ecosystem services. And then the second one is how to grow stewardship in ways that are inclusive. I know that there's a lot of people in academics that believe that if we just teach people enough, they'll do the right thing. But we all know diets don't work, and it doesn't work in the case of stewardship either. People seem to respond to emotional reasons, and so I'm trying to see how emotional reasons and ecosystem services can go together. Okay, I'm going to just go back to this one for a second. We all know that global climate change threatens the structure and function of ecological communities, and because most of us live in cities, I'm particularly interested in how to adaptively manage urban green space, whether it's private space or public space. So what I did was I used ecological principles to develop and adapt a strategy to support the resilience of urban spaces with respect to the plants that provide us with the ecosystem services. In other words, the key basis of green infrastructure. The strategy uses 5 different principles, 4 of which are straight from ecology, of how to deal and grow resilience in the face of uncertainty. So for the development of this insurance policy for ecosystem services, I'm going to give you an example because it's just the easiest way to explain it. So the first ecological principle is that of functional redundancy, and this is where a number of species contribute to the same ecosystem function. So if you look at the long bar, you'll see that that is the month of July, and the horizontal bars are the time that nectar-producing flowers are available to pollinators. And so you'll see that from May to September, there's always some sort of nectar resource for a generalist pollinator. In the month of July, it happens to be the highest. So this is a good example of that type of redundancy that works well. Next, there's resource diversity, and that's a situation where you're looking at all the same ecosystem functions, pollination, but you're looking at plant species that have really different abilities to deal with environmental conditions. So if you look at the column called soil moisture, look at the last 2 species, you'll see that here's an example of 2 that are around toward the end of the season, but they differ in their ability to deal with differing soil moisture conditions. Now we could always pick the highly plastic one that does well in dry, moist, and wet environments. But if we did that across the city, we'd have really lowered biodiversity across the area. So the best thing to do is to add ones that have a plasticity in that range that goes toward whatever the predictions are for the local regional model for climate change. The next is plasticity. Now this is an individual trait, but collectively looked at across the entire community of plants, you can get an idea of what needs to happen. I've chosen hardiness zone because overwintering hardiness is one of the main reasons that people manhandle plants and plant them someplace. Will this survive the winter? So you can see there's a lot of plasticity and capacity to deal with the cold of winter. There's also could be a heat hardiness index on this, but I've just stopped at this. And you'll see that some have relatively narrow ranges and some have larger ranges. And the design for which these were chosen, those narrower range ones like the swamp mallow, was chosen because it has certain capability for the northern creep of heat. So by choosing that species, I'm adding to this list a form of assisted migration. And finally, there is second to last, environmental things are structural diversity, and all that is how spatially configured things vary so that there's more habitat for more species. And finally, there's aesthetic traction, And this is engaging, developing an engaging aesthetic that can have a positive outcome that supports the sense of place or provides pleasure because people will fight to preserve what they love. So how to get there? Well, you create a big database that's got all the information about development and ecology like I was just describing to you. Then you design green spaces specifically using these rules for resilience, and you select the plants that are in the range that best target what the local model predicts is going to be in that place, and whatever cultural components provide sense of place to people for that emotional attachment. And then you multiply that planting scheme across the city in a network of street corridors that link existing green space, and then you figure out how to pay for it. And figuring out how to pay for it might be the hardest part of it because there is not political will or a lot of money really to cover this. But I've done several pieces of research that suggest that there are ways to do it from the bottom up. The first piece of research shows that people are more likely to participate in communal replanting when they've lost a tree in front of their house or a tree in their yard. And so winters like the times we have could precipitate that, just that sort of thing. And the second one is that, you know, all the curbside plantings in Ann Arbor, well, I did a spatial study of their distribution, and there is social contagion that's present in how they are distributed. And a follow-up piece of research that's just under analysis right now is showing that the first installers were people that dominantly had ecological reasons for doing it, but everybody that copied, who are the majority of people, did it because they liked what was across the street. So given that, we won't have to go through this list of things. I would say the main things about this adaptive strategy that are just great is that it can aim and hit a moving target as best as we can imagine at this point without any good back data to check it against. And that is assisted migration, which is greatly discussed in terms of trees and silviculture. It's a way to do that inside of cities and even to test things out. The last thing is that my related teaching are ecological planting design studio for landscape architects and an urban agriculture class. Surprisingly, everything I've told you is related to the way the urban agriculture community works from the bottom up. Civic engagement, a lot of outreach studios. The most recent one was one of a succession of ones of designing for the Detroit Greenway, using these same kinds of principles, and consulting for the Udolph Detroit team on Belle Isle. And those are the references that are related to what I spoke about. Thank you.